Today's homework, we're reviewing how to do dilution questions. And in brown on page 150, we have a question that asks us that if we're starting with 3 molar sulfuric acid concentration, how much is needed to make 450 mLs of 0.1 molar sulfuric acid? We use the dilution formula to solve this problem. And it's written M1V1 equals M2V2. And I've just introduced this constant because the amount of sulfuric acid in the solution is the same before and after the dilution. The only difference is there's more water in the diluted form. So the number of moles is the same. And when you take molarity and you multiply it by volume, so units of molarity is moles per liter, the volume is in units, has units of liters. Liters cancel, you get moles. So we're familiar with this piece of the formula. So if you have an initial set of conditions and a final set of conditions, that's why you have M1V1 M2V2. So we use those subscripted variables to show it. You see, typically, whenever you have 3 pieces of information and they're asking for a 4th, and it's a dilution problem, that's the formula you're going to use. You can use it without the n written in the middle. It's just like that. Anyway, we enter the variables that are missing. We solve for the one that we want to find, which is the volume of the initial solution, and it turns out to be 15 mLs. The second question, it asks you to find the volume of how much volume of a solution which has a concentration of 2.5 molar is needed to get 0.5 moles of lead plumbous ion. So we use the equation n is equal to molarity times volume, so we just use 1/2 of that equation. There's only 3 variables. They've given us 2, so we need to find the third one. We transpose the m to find the volume. So here are the conditions. 0.05 moles of plumbous ion from a solution that has a concentration of 2.5 moles per liter. Moles will cancel. The liters is the denominator of the denominator, which turns into the numerator. So it gives us 0.02 liters. We multiply by 1,000 to turn it into milliliters. So it takes 20 milliliters of solution to isolate 0.05 moles of plumbous ion. Third question in the assignment. How much of a 5 molar solution of potassium chromate is needed to prepare 250 mLs of a 0.1 molar solution? So you see 3 pieces of information, and they're asking you to dilute something, so definitely we're going to use the M1V1 M2V2. We isolate the variable.
Excuse me for the interruption. Teachers, please dismiss the junior boys volleyball at this time. Once again, teachers, please dismiss the junior boys volleyball. Thank you.
Enter the values, and we get 5 mLs as the final result. In the third question, 10 mLs of 10 molar solution is diluted to 250 mLs. What is the resulting sodium hydroxide concentration? When you put square brackets around something, it means concentration. So that's how you would read it. Quotation marks, sodium hydroxide concentration, square brackets. Again, we use the dilution formula. We solve for M2. We isolate M2 in the equation. Plug in the variables we know. We get an answer of 0.4 molar. Which brings us to the next concept, the concept of writing stoichiometry. It's a new fancy word. All it means is proportions of the reaction. When solving problems that require equating the mass of one substance into the mass of another substance being produced by the chemical reaction, it is necessary to take into account the stoichiometry. Here's the stoichiometric coefficient. In this reaction, lead nitrate, plumbous nitrate is reacting with potassium iodide to give you lead iodide and potassium nitrate. For every 1 mole of potassium nitrate, you need 2 moles of potassium iodide for the reaction to proceed normally. So this is helping us to balance the reaction. We have a sample problem on the last board. Most, if not all, problems involving stoichiometry follow the pattern of going from grams to moles, through the stoichiometry to moles of some other substance in the reaction, back to grams. And whenever you want to convert from grams to moles, you have to divide by the molar mass. If you want to convert from moles to grams, you multiply by the molar mass. Always go to moles when you solve these type of problems. We're always seeking to go to moles of one thing to moles of the other thing. That's how you equate the substances that are involved in the reaction. Now, using this reaction as an example, the question I asked was, if you had 25.2 grams of plumbous nitrate, this substance, and it was reacted with an excess of potassium iodide, which is this substance, how much potassium nitrate forms? First step, we're starting off with grams of potassium nitrate. We're going to divide by the molar mass, which is this. This is how we calculate it, to give moles of lead nitrate. Then we go through the stoichiometry. What is the stoichiometry? It is 1 to 2. For every 1 mole of lead nitrate that's consumed, you need to consume 2 moles of potassium iodide. But what they're asking us here is how much potassium nitrate forms. So there's, for every 1 mole of potassium nitrate, 2 moles of potassium, for every 1 mole of lead nitrate, 2 moles of potassium nitrate forms. So we're going to use that in the stoichiometry. 2 moles of potassium nitrate forms for every 1 mole of lead nitrate that is consumed. This allows us to cancel the moles of lead nitrate, and it will give us an answer in moles of KNO3 that form, essentially doubling this number because it's 2 to 1. Then that puts us over here in the solving of the problem, moles of potassium nitrate. Now we want to go to grams of potassium nitrate. So we're going to multiply by the molar mass. So to go from here to there, we have to multiply by the molar mass. Here's the molar mass of potassium nitrate calculated. And we get an answer of 15.3848, so on. We're only allowed 3 significant figures, so we report our answer to 3 significant figures. There was 15.4 grams of potassium nitrate will remain in solution, because it's soluble, if you react 25.2 grams of pumice nitrate with an excess of potassium iodide.